Okay, so we're thinking about some figures here. We have these two triangles, and we are given some really key information that these triangles are congruent. So our math brain goes congruent, congruent. Well, congruent is just a fancy math word for the same. So they have the same measures, the same angles. So what we're going to do then, knowing this, is that we're going to then list all the pairs of congruent sides and then all the pairs of congruent angles. So let's try that out. So first things first, we know we're given the information that we know these triangles are congruent. Now, when looking at them, right, they do kind of look similar, but it's hard to tell that they're exactly the same because they're kind of like floating in different positions, right? But if you did cut these both out of paper and you flipped them so that they lined up, right, you would see that they are the same. So if we imagine that we flip them both kind of the same way, right, we could see that this P is the same point, the same vertex as W, right? We can, if we kind of flip it, and that then R is the same point or the same vertex as Y, and that then Q is the same as V, right? So those are all sort of equivalents, they're congruent. Now, with that, because those points are the same, we can make some statements about the sides. So first, with the sides, we can say that going from P to Q, or pink to green, green to pink, these are the same. So these sides, we can mark them with a hash mark, right? So we could say that they are 1 hash mark long, however long that is in a measurement. We could also say that going from P to R, or green to yellow, is the same. So these could be called 2 hash marks long, say. And then the final side has to also be equivalent. So we know that from Q to R and V to Y, those are all the same. So we could mark those and call them 3 hash marks long. All right. So then what can that tell us sort of about our sides? Well, you can write it down in this space on your paper if you want. I'm going to write it over here because I have more room. So we can say that this purple segment VY is congruent to segment RQ. Those are the same length. We could say that same thing about our green ones too, right? We could say segment PR is congruent to segment, what else is green? WY. We want to make sure to put our segment sort of cap on, if you will. And you could say that same thing about the blue, right? The V to W and the P. So then what about our angles? Well, if we look at sort of these dots, remember we kind of found the dots that were matching up. Well, we know that R and Y, we marked them with a yellow dot, right? Implying that if we lined up those triangles and put them right on top of each other, they would be the same angle. So what we can do is in your angle section here, you could say that angle Y from this triangle is congruent to angle, which one over here? Angle R, right? You can do that same thing for all of them. So we have this angle P is congruent to, what's the other green one? Angle W. And the same is true for that final one, those pink dots, the Q. Angle Q is equivalent to angle V. So your notes might look something like this in a more tidy way. Feel free to pause and make your notes look like that. When you do number 2, you're going to start the same way. Think about if I cut these out and rotated them and laid it on top of itself, right? So that the angles matched up and the sides matched up, you can then go from there and say your which sides and angles are congruent to which sides angles. Down here, we are trying to determine if these triangles are congruent, are the same. And in this case, we know that their angles are the same, 40, 40, 70, 70. However, their side lengths are not. You could not cut out one triangle and plop it on top of the other, so they are not congruent. They're similar, but not congruent. So here we would say no.